Hello everyone. So today we will be learning about Thevenin's theorem. So it states that any two-terminal linear bilateral DC network can be replaced by an equivalent circuit consisting of a voltage source and a series resistor. So for example, here we have a circuit. So it has one voltage source and multiple resistances. So what this theorem states that we can replace this whole network by a single resistance in series and a voltage source. So this circuit will look like this here. So let's look at an example and we will learn more about it. So now we have to find the unknown current flowing through the circuit. So here we have two voltage sources, E1 and E2, where E1 is 100 volts, E2 is 70 volts. We have three resistors. Let's call this R1, R2 and R3. So now first we have to select a load resistance. So here I am selecting 160 ohm as my load resistance. So RL is 160 ohms. So to find Thevenin's voltage, first we have to remove these 160 ohm resistors, and there will be an open circuit between this node, let's call this B, and ground. So yeah, so now this resistance is connected to the 100 volt source. This resistance is connected to 70 volt source. When we apply Kirchhoff's current law at node B, we get VB minus 100 volts by 20 ohms plus VB minus 70 volts by 20 is equal to 0. So now VB minus 100 plus VB minus 70 is equal to 0. We take 20 as common and we multiply it to 0, so it goes to 0. Now 2VB is equal to 170. Therefore we get VB is equal to 85 volts. And now this voltage will be our Thevenin's voltage, VTH. Now we have to find Thevenin's resistance. So to find Thevenin's resistance, first we have to turn off both the voltage sources. E1 will be 0, E2 will be 0. Then we should not connect the load resistance yet, so the circuit will look as if both R1 and R2 are connected in parallel. So the circuit will look like this. R1 and R2. So now this equivalent resistance will be our Thevenin's resistance. So RTH will be 1 over R1 plus 1 over R2 inverse, which will be R1 is 20 ohms, R2 is 20 ohms. So 400 by 40, which will give us 10 ohms. This is our Thevenin's resistance. And now we have to draw our Thevenin's equivalent circuit. So it will be, now we have to connect our load resistance, which will be 160 ohms. RL is 160 ohms, VTH which was 85 volts, and RTH which is 10 ohms. So to find the unknown current flowing through this circuit, we have to use Ohm's law. So V is equal to IR, therefore I is V by R, therefore I will be 85 by 170, sum of these two resistances. So 85 by 170 we will get 0.5 ampere. So this will be the current which is flowing through the circuit. We have found this current by using Thevenin's theorem. So I hope you have enjoyed this video. More concepts will be covered in the upcoming videos, so stay tuned. Make sure you subscribe to the channel so you don't miss another update.